Yes, today's topic is aldehyde and ketones, and I have taken the preparation, and it is set number 8 for the practice set. And these questions are from the different types of entrance exam. I have not written alongside of these questions from IIT, from JEE, from TMT, from CEET, and lots of entrance exam questions are here will be discussed. Please minutely follow. I'll solve out the question, and this is specially on preparation. So first of all, acetylene, when it is made to react with HgSO4 and H2SO4, and again A is formed, and A is made to react with CH3MgBr, B, and B is oxidized to give C. What is A, B, and C, or what is final C? Very simple. C, you see the technique. I will just show you the technique. So first of all, in my first class I have already mentioned this one. Acetylene, when ethyne is made to react with Hg2 and H positive from sulfuric acid, in dilute condition water is there. So what's happened here? H2 and O is added. Am I right? So I told you in the first class, then O is added to that carbon along the triple bond which has less number or no hydrogen at all. But here both the carbon has same number of hydrogen. So where in which carbon you will add up hydrogen and in which carbon you will add up O, it doesn't matter, you do. So I am taking O here and H2 here. So you are getting the answer is H CH3 and CHO. This is your A. So if you write O in this way, this is your A. And when it is made to react with this CH3MgBr, so CH3MgBr, you know it is Grignard reagent, and very often I tell this is minus and this is plus. Am I right? This is minus and this is plus, and this is a bit minus and this is plus. A little minus means del negative and del positive. Bond is withdrawn in this way. Am I right? So this is negative and this is positive. So negative part get attached to this one. So here you are getting CH3C, and this Grignard CH3 will come here, and along with O, the positive part MgBr will get attached and hydrogen will remain the same. And you are asked it is oxidized. So before oxidation, this is an intermediate part, and this always follows hydrolysis. So hydrolysis means water breaks up in this way. Am I right? So you will get CH3 CH CH3 OH, 2 degree alcohol. Am I right? So your B part is this. So what is C? C1 oxidation. C1 oxidation, this will give you here, there is one hydrogen. If there is two hydrogen, it is aldehyde. If there is one hydrogen, it is ketone. So you know yourself, because when this is CH2OH, that becomes CHO. When it is CHOH, that becomes CO. When it is CHOH, that becomes CO. If it is CH2OH, that becomes CHO. Hence CH2OH, CHO, CHOH, CO. Hence I have written that part is equal to this two part is equal to CO, and this CH3, this CH3. This is your C. This is the answer of the first question. The second question is again very famous reaction. Again in my previous class I have already shown you exemplar solution. I have explained this one. If you go through this one, and those who have not seen, for them again I will discuss. And this is a famous reaction. Acid chloride RCOCl3, CH3COCl3, benzene COCl3, anywhere COCl is there. Am I right? So in place of COCl, just you remove this by H. Answer is RC double bond of H. What you are getting is aldehyde, and that is the famous reaction. It is Rusanman reduction. ROSENMUND, Rusanman reduction. And the very important reagent you can understand when you will find hydrogen palladium over barium sulfate. This is the best reagent Rusanman used for acid chloride COCl to CHO. And whatever the complicated structure in the backside attached to COCl, answer COCl will become, in place of Cl it will become H, and this is Rusanman reduction. So number 3, acetophenone is prepared in Rusanman-Sandmeyer Wurz. Sandmeyer is diazobenzene. Wurz reaction is alkane preparation. Rusanman means R or COCl to CHO. You are asked to acetophenone. What is acetophenone? Acetophenone is this. Am I right? You have to get this one. So answer left is this. So how will you get? You see here benzene plus CH3COCl anhydride aluminum chloride, then this chlorine will get attached to this catalyst. So COCH3 will be electrophile, and that electrophile will enter here. You will get this. So it is actually Friedel-Crafts acylation reaction. In first year you have got it, and you are asked in a different way. Acetophenone, you know the structure. Acetophenone is prepared from Friedel-Crafts reaction. It is not given, acylation is not given. You should know this. So next part is compound gives acetone on ozonolysis. So I have a lots of questions, a lots of options are there. Other two options I have not written. I will just tell you the main fundamental point from which you can understand ozonolysis. You need not go through the process of ozonolysis. You need not check for each option. You see, the first option is CH3, CH double bond, CH bond, CH3. When ozonolysis happens, then double bond becomes ozonide. Am I right? Double bond becomes ozonide, and it backs in this way. So CH3CHO, CH3CHO. No matter you, from first one you are getting CH3CH aldehyde. So acetone is only possible here because when CH3 is side by side. So here in this case, what you are getting here is, you see CH3 C CH3 double bond CCH3 C CH3. Am I right? When CH3 CH3 double bond means CH3 CH3 C double bond, you are getting natural acetone, because here there is ozonide. When you break this one, that will become CO, that will become CO. So this is the point. Whenever you are getting CH3 CH3 side by side in one part, and this part may not have this, may not have other thing, but in one part of the double bond, one side of double bond, you should go CH3 CH3 side by side, then you will get acetone. This is the technique. You need not do ozonolysis. So this is a bit typical. So I will try to give you the answer. I will not give you the mechanism. It is C2H5 sodium hydrolysis, sodium hydroxide and water hydrolysis is done in case of basic condition. So here what's happened, here hydrogen is added and C2H5, here hydrogen is added. I am not showing you the tree, the process. This is actually CH3CO CH3, and here C2H5 OH and some other mechanism that I am not showing. It will take a bit time. If I get time, you will show in the option. You are given CH3CO CH3 and C2H5 OH. A and B options are correct. You will get acetone and ethanol. Next one, which of the following is prepared in the laboratory from benzene? Glyoxal? No, no matter of glyoxal. It is unnecessary. Cyclohexane? Unnecessary. Acetophenone and hexabromocyclohexane. I am talking about these two, and this is also not in the required condition. Acetophenone is prepared in the laboratory. Means from the benzene acetophenone, if you want to get acetophenone, in the laboratory process, I have already mentioned this is acetophenone. So you can use Friedel-Crafts alkylation process, acylation process by anhydride aluminum chloride, and this chlorine will get attached to LCl, Cl3 will become Lewis acid, will become LCl4 and COCH3. CO will be electrophile will attach with this one, and this is nothing but a laboratory process of preparation of acetophenone. Hence, answer it will acetophenone is prepared laboratory from benzene. In the laboratory, when benzene from the benzene will get acetophenone. This is appeared in AIMS exam. Another question is very simple again. HC triple bond CH HgSO4 and sulfuric acid. Dilute means water is there, and you are asked to get A, and when A is there, you are guessed to B. So first one you can very easily understand, because when water is there or when Hg2 positive and HgSO4 and H2SO4 is there 1% or 20%, am I right? So I have shown you, in one place you give H and other place you give this, so you are guessing CH3, C double bond O H, am I right? But the question A is very simple, you have got this one, but when sodium hydroxide is there, so this is aldehyde, am I right? So there is aldol condensation, because aldehyde on sodium hydroxide gives you aldol condensation reaction. Dilute sodium hydroxide is there here, dilute is not mentioned, but till it is aldol condensation. And I have told you aldol condensation is very simple, because two molecule of CH3, you write in this way, in the reverse way, you write one is electrophile and other is nucleophile, am I right? So it will be drawn here, this will be plus, and here this will attack here. So this is negative and this is partially positive, and this will get attached here, and you write in this way, oxygen here and hydrogen here, and this is a bit negative, partial negative, am I right? So this will come here. This is the technique. So the same ethanol is arranged in reverse order. One is electrophile, other is nucleophile. In this way, we are connecting these two. This is CH3, then this is CH, I have written here, and in place of O and H is attached here, and this is here. So your answer of B is this, am I right? Answer of B is this. You follow the trick, otherwise aldol condensation cannot be done, and instantly you should think of sodium hydroxide when aldehyde is there. Largely when aldehyde is there and sodium hydroxide is nothing but aldol condensation, but there is a hint it should be dilute. Barium hydroxide is also there. With the help of barium hydroxide you can do also aldol condensation. So next one is here again very simple one. Question number 8 is CH3 COCl. You are given Hg SO4 and H2SO4, and answer is given CH3 CHOHCl, and you are asked name the reaction. Very simple. A bit earlier I have told you COCH3, in place of C you are getting you are getting H, am I right? Means CH3 C double bond O Cl is converting to CH3 C double bond H. Simple, in place of HCl you are getting H. In presence of no, the reagent is twice hydrogen and palladium over barium sulfate. This is nothing but acid chloride COCl has become CHO, and the reagent is H2PD BSO4. It is not Rosenman reduction. The name is Rosenman reduction. I have given already. The question is about a lot of exam in various type of entrance exam. Thus this question is been asked. I have not written all the exam name. Next one, oxidation of toluene to benzaldehyde by chromal chloride. Oxidation of toluene. This is toluene. I will explain. benzyl chloride, and you are getting benzaldehyde. You are given oxidation of toluene to benzyl by chromyl chloride. What is the reaction? Very famous reaction, everybody of you knew, Ithard reaction, and a lot of questions on Ithard reactions are there. There are some intermediate compounds are there, very often asked what is that intermediate. I will in bit by bit during the discussion of lots of questions answer in entrance exam, I will show you the different part or different phase of the Ithard reaction. The Ithard reaction, the special reactions where toluene is converted to aldehyde in presence of chromyl chloride. Yes, next question number 10 is which one of the following on heating with sodium hydroxide produce aldehyde? A lot of option is given. You need to get RCHO, but the option is this is the correct option out of 4 options, and this halide is called gem halide. Sometimes you are asked in the exam what is gem halide, what is vicinal halide. If in the same carbon 2 halogens are attached, it is called gem halide, and in the 2 adjacent carbon halides are attached, it is called vicinal halide. So this is gem halide, and this on hydrolysis hydroxide gives. So I am arranging this as like this, and out of this we will remove water molecule. So if you remove water molecule, say the trick, the water molecule goes in this way, you are getting CH3CHO. So this is the option which gives gem halide. Generally you can't imagine how you will get, so just you follow the trick. Next one is, this is the question, CH3 CH2 on X this gives this. You are asked what is X. You can't understand how what is this X. Actually the X is, in very often I told you, when triple bond is there, when alkyne part is there, when it is alkyne, then it is hydrolyzed and H2 and O is get added, and O is get added to carbon having less hydrogen or no hydrogen, H2 is to the opponent. So you are getting CH3 CH2 CO, and H2 is here CH3, and that is done when it is HgSO4 and H2SO4. So here X is equal to HgSO4 and H2SO4. Very often the question comes. Next question, on dry heating with calcium acetate, a lots of exam this question is asked. What is calcium acetate? This is calcium acetate. It has come from acetic acid. CH3COOH. Remove H, you give CH3CO. Acetic acid. This part is acetate. CH3COOH. When you this remove, this is acetate part. So this part in this way, calcium acetate. When it is dry distilled or heating, dry heating, you will get only CH3CO, CH3 acetone. So this is very important, and when it is calcium formate and calcium acetate to mix, One is, this is two molecule, there is two molecule. I have not shown the way how you get two molecule is there. When you assume two molecule of same calcium acetate, you will get acetone, and when one molecule calcium acetate, one calcium formate HC, you will get aldehyde. Next and last of today's class is this CH3 CN What is ABC? First of all, this is reducing. So CN on reduction becomes CH2NH2. CN on reduction becomes CH2NH2. Those who cannot understand how, you keep it in your mind, then the answer is very simple. One H is here, another H is here. Addition of hydrogen is called reduction and removal of hydrogen is called oxidation. And here also one oxygen, hydrogen and one hydrogen. So the answer is CH3 CH2 NH2. So simple trick is that CN on reduction will become CH2 NH2. Chain is increased, carbon is introduced. Now this A, when treated with HNO2, it is famous reaction when amine, primary amine reacts with a nitrous acid in benzene diazonium chloride. If you have got, you get diazonium salt. Since it is aliphatic, alkyl diazonium salt. Alkyl diazonium salts finally gives you alcohol. So famous reaction, amine with NH2 gives you alcohol, CH3 CH2 OH. So you are getting, treating A with this, you are getting B. This is your B. B on copper 573 Kelvin. This is oxidation. So oxidation of this gives you CH3 CHO. We know on oxidation CH2OH becomes CH2. CH2OH on oxidation, on reduction, this is CH2NH2, and on oxidation that CH2 groups converts to CHO. In very often in various class, different class, I have shown you the trick. You should keep it in your mind. So this is all about of today's class on preparation and different type of the question set from the preparation parts of aldehyde and ketone. And now so at the very fag end of this class, I am summarized the class on preparation of aldehyde and ketones. Some important reaction you should keep it in your mind. Ethyl reaction is equal to toluene equal to bromyl chloride ins carbon disulfide, and acid hydrolysis gives you this. You should keep it in your mind. Dimerthymine, it is very important reaction. Very often question asks. I will ask you what type of. I will tell you the type of the reaction very often asks in the entrance exam. And when you know that phenol chloroform plus sodium hydroxide gives this product, and Nussbaum reactions RCOCH2, or this may be benzene part, phenyl part. This just to change COCl, and the reagent is H2 palladium over barium sulfate equal to RCHO, and Gattermann-Kuss reaction is CO and HCl aluminum chloride equal to CHO. It is very important reaction also. You just keep it in your mind. About Raman-Thamman, I am just giving the mechanism. Very often you are asked what is the electrophile used in the Raman-Thamman reaction. Answer: electrophile used is here is dichlorocarbene. This is electrophile. You never imagine from the reaction what is the electrophile name. Generally, you can't understand this one. Please see the mechanism in a very short way. So from base sodium hydroxide, you get OH. OH and chloroform reacts. You give CCl3 plus water, and from this uh, one chlorine is left out, so you get CCl2, and this is dichlorocarbene, and this is electrophile, and that dichlorocarbene reacts with the benzene OH phenoxide. So, and this bond would go here, and this extend this bond towards this one. Attack is in this way, so this get attached in this way, and hydrogen just I have shown you here. So next part, hydrogen is gone to this place. When it goes to this place, this bond is inclined to this, and this bond goes to this. So here you are getting O negative CaCl3. Now when you will get 2 molecule of sodium hydroxide, then 2 molecule of sodium chloride and 1 molecule of water is get released. So here you are getting CHO, and here ONA. That Na will be released later on. So you will get ONaCHO. This is in short the mechanism of Raman-Thamman, and main motto of the showing the mechanism is to show you the electrophile generated in Raman-Thamman reaction. This is all about of today's class, and the sum up of the class is very important. Please minutely follow the class and go on practicing this set number 8. Thanks a lot for watching the class, and hope you will never forget to subscribe the class to remain updated.